So this is where we try to tell if two graphs are isomorphic. In general, you do the problem without being told which edges go to which. I meant to say vertices, whoops. Okay, so what you do, since they've been paired for you, you have lots of options. What you need to do is do an inventory of each individual edge and see if they're in both graphs. So because we have the list, we could just start saying, 1 goes with E. So you could put the E here, and E is 1. 2 is C. This is if it works. 3 is D. All right. 4 is H. 5 is J. 6 is B. 7 is G. 8 is F. And 9 is A. So there you go. You don't have to do both sets. And in fact, you don't have to do either set if you don't want to. I'm being complete. I'm doing every possible thing you might think to do. And as long as you only do some of them, it's enough, provided you do enough to demonstrate that you've done a proper inventory. So one thing you could do is just start listing off all the possible edges in the first graph and seeing if they're in both graphs. But it could be tedious because you could list EC and then CD and then DJ, and that, again, that's just tedious. So you could say inventory edges by making paths. Okay? And so when you do this, you might say E, C, D, J, B, F, G, H, E, for example. And then you're going to go like EC, CD, DJ, JB, BF, FG, GH, and HE, but I could still make more path. I could still say, now I'm at E, I could go to F, and to D, and then to B. Now I'm kind of stuck. So I can just make another path. I can start at H. Start at C. C to H. H to J. Put a period at the end of the first path just so you know what I'm doing here. I'm at J. I might want to go back to H. Wait a minute. What CH? Oh, I did mean to take this path. I just didn't highlight it yet. And then to A. And then to H. And then I'm going to have one more edge that's just all by itself, GA. Now if I hadn't already done this pairing, then I wouldn't be able to just trace it out down below. And in that case, I'd have to translate it. So just in case you didn't do that little bookkeeping trick, I'm going to then say this is equivalent to what? Okay, so E is equivalent to 1. So every time I see an E, I put a 1. C is 2. D is 3. H is 4. J is 5. B is 6. G is 7. F is 8. And A is 9. And that's okay, I forgot D. D was 3. Okay, so again, I don't have to do that if I've already got all the labels copied over. Okay, so now I'm saying I have a path 1, 2, 3, 5. So I have a path, well, see, now I'm whatever. 1, 2, 3, 5. I was using the letters on the number path and the numbers on the letter path, whatever. 1, 2, 3, 5, 6, 8, and 7, 4, 1, 8, 3, 6, 2, aha, wait a minute, 6 to 2. Oh, that's right, because this was the end of a path, so we're done. 2 to 4, okay, 2 to 4, 4 to 5, 5 to 9, and 9 to 4. Yes. Good. And then 7 to 9. Yes. Okay. So then you would say, I did the inventory. Both graphs are identical. And that means isomorphic.